needed for my acceleration graph. But what do the innards look like on my displacement and my velocity time graph? So we're going to use the same equations we used up here to solve for our displacement at time 1, our displacement at time 2, our displacement at time 3, and so on. And our velocity at time 1, our velocity at time 2, velocity at time 3, and so on. So my displacement at time 1 is going to be my initial velocity times 1 squared. So 49 minus 4.9 gives me 44.1. I have displaced 44.1 meters at time 1 seconds. So at time 1, I'm going up 44.1. We're going to do the same thing for time 2. So my initial velocity time a time of 2 plus 1/2 so at time 2, I've been displaced 78.4 meters. So at time 2, I'm going up 78.4. We're going to do this for time 3. So my initial velocity times time plus 1/2 my acceleration times squared. So I'm almost at 103 at time 3 seconds. And at time 4 seconds, times 1/2 my acceleration times my time squared gives me what did I do here? Shoot, I need a calculator. No. 7, 2, 12, 13, 14. 6 and 1. Let's see. 9.8 times 8. 72 plus 8 is 78. Gives me 6, 5, 8, 1. What is it? 7, 1, 1. Oy vey. Long multiplication. Product of the 80s and 90s. Okay, so at time 4 seconds, I'm at 117.6. And then I know my way up is going to mirror, or my way down is going to mirror my way up. So you are welcome to plug it into your kinematic. But I'm comfortable knowing that because this thing is accelerating, And it's going to have a change in rate that is consistent. Here we are. So this is my position time graph for the 10 seconds. My velocity time graph, the math is slightly easier. So we're going to use this equation here. So my final velocity is equal to my initial velocity plus acceleration times time. My initial velocity is 49. 9.8 times 1 gives me 39.2. So at time 1, I'm going at 39.2. At time 2, I'm going a rate of 29.4. At time 3, I'm going at a rate of 19.6. And at time 4, I'm going at a rate of 9.8. This, you should see, is going to be a straight line. So at time 5, I'm at 0. At time 6, I'm at negative 9.8. At time 7, I'm at negative 19.6. At time 8, I'm at negative 29.4. And then at time 9, I'm at negative 39.2. If you are not comfortable with this, you can do the math yourself and see that it will work out. So I'm going to take my straight edge, draw my line through here. So here you have it, graphs, position time, velocity time, acceleration time for an object that's in the air for 10 seconds. I'm having you plot one of your problems that you worked out previous, your number 10 on your free fall practice problems. That one is a drop from some height. So this is starting at rest, or starting at the ground level, excuse me, not at rest. It's being projected into the air and it falls back down. Something that is being dropped from a height, your graphs are going to look like this. Half the flight. You're starting from some higher position, going to some lower position. Your initial velocity when an object dropped is 0, and you're going to be accelerating at negative 9.8 meters per second. So in keeping with our information we can get from our displacement time graph, velocity time graph, right, for an object that's accelerating, my velocity time graph will yield me, the slope will yield me my acceleration. So this slope here is going to be negative 9.8. Also the area under the curve here, right, it gives you displacement. It can be positive or negative. So you would find it, because this is a triangle, 1/2 my base times my height. This displacement is positive because I am in the first quadrant. This displacement is negative because I'm in the fourth quadrant. So 1/2 5 times negative 50, right? That gives you a negative number. If you look here on this graph, right, my displacement to begin with is positive. I'm going up, I'm moving in a positive direction. And at this middle point here, I'm starting to move in a negative direction or back down. I hope this was helpful. Try the practice problem I assigned to you, plotting the graphs. Remember, you need to find your maximum height, your maximum time, your maximum velocity before you start plotting these, so you know how to make your X and Y axis. And remember, the one I gave you, you're just plotting the downward motion. So you can do this math with the numbers that are applicable to that problem I gave you. and this is what your graphs should look like. Make sure that the scales are appropriate before you start plotting. Let me know if you have any questions.